Good morning, scientists. So, your job today, you've got two tasks. Number one, get the remediation done. That's due by midnight Sunday. If you got a notification from me yesterday through Canvas on the inbox, that means you didn't score high enough and you need to get that remediation done. So you answer the questions, fill them out, submit them to me, and I'll go ahead and grade those, and I'll update it in Pinnacle over the weekend or on Monday. Now, if you're looking in Canvas and you see that some grades are done, some of the recent assignments they're done, you've got credit for it. Yet you look on Pinnacle and it's different. Don't worry. What I have to do is I have to update everything to Pinnacle every so often. I don't get to do that every single day. So it's usually a couple times a week I'll transfer everything from Canvas over to Pinnacle to make sure the grades match up. Same thing with the remediation. Once I grade all the remediations, then I'll go ahead and update that to Pinnacle. I did it for a few of them, but if you did the remediation, you got a grade on it, yet it doesn't show up in Pinnacle, I'll get to that probably, if you did it today, yesterday, I'll have it done by the end of the day today. If you do it over the weekend and have it done by Sunday, probably the end of the day, Monday, I'll have that updated there. All right, your other job. There's a video about Kepler's first law. So Kepler's first law video and the quiz. As you watch the video, take some notes on any new terms or new ideas that you're not unfamiliar with. Write those down. Now you could pause it, write those things down, then play again. Another thing that would be helpful is turn the captions on. It's a YouTube video, turn the captions on there. You can even change and adjust the playback speed. A lot of students have told me that they like playing it back at about 0.75, so about 75% speed. If you do that, she speaks a little bit slower, it might be a little easier for you to understand. So you might want to watch it once regular, then watch it a little slowed down, and then take some notes on it, so that way you know what to expect. All right, that's your other job there. Now some of the key ideas for today. The first key idea is about orbits. So an orbit is the path an object would take around another object. So let's say if I was orbiting around this flower pot here, one object, the path it goes around the other object, usually it would be orbiting a smaller object, it's going to orbit a larger object. That would be the orbit. So that orbit there is also the same as a revolution. So a revolution and an orbit, they actually mean the same thing. So again, as I'm orbiting the flower pot here, or I'm revolving around the flower pot, those two things mean the same thing.
One of Kepler's key ideas was that the orbits are not circles, they're actually ellipses. So in these elliptical orbits, I'm going to demonstrate how to draw an ellipse right here.
So you've got 2 points that would be called, each point is called a focus, or the plural of focus would be foci. So I have a loop of string right here. You could do this at home. If you take a cardboard box, a couple push pins or nails, stick them in the cardboard, and then make a loop of string that's a little bit bigger than these two right here. I'm actually going to just do it with one, and as you can see, if I go around this way, it simply makes a circle. So if I have just one focus, there's just a circle. If I put it around both of them, and this is what Kepler figured out, is that the orbits are actually elliptical shape. So here's how you could make your very own ellipse. And you could even, if you play around with this on your own, you could experiment and put these closer together, farther apart, and find out how that changes the shape of the ellipse. The more elliptical it is, the more oval, we call that its eccentricity, the more eccentric it is. Now, most of the planets in our solar system, the orbits are pretty close to circles. That's why it took people hundreds of years to figure out that they're not perfect circles, they're actually ellipses. So there's some objects in our solar system, like comets, that comets have highly eccentric orbits. Or Pluto also has a fairly eccentric orbit compared to the other planets, and that's why sometimes Pluto's orbit is closer than Neptune, sometimes it's farther away than Neptune because of that eccentricity in its orbit. So that's the story with the ellipses. Go ahead, try that at home. Try to make your own ellipse using a couple push pins and some string, and you could experiment putting them closer together and farther apart. If you use a different colored pencil or marker for each of the ellipses, it makes a pretty nice looking pattern. So if you want to get artsy with it, there's something for you to do. So
Next topic.
So, gravity is what's responsible for creating that shape, that ellipse. That elliptical shape wouldn't be there without gravity. So when we have an object, like a planet, or a moon, or a sun, its mass actually makes a dent in space-time. So the way gravity works is if you have a more massive object, it's going to have more gravity. A less massive object is going to have less gravity. So this one, if you're on the surface of this object, you'd feel heavier. If you're on the surface of a less massive object, like the moon, you'd feel less heavy. You'd have less weight. So the other thing that also will affect gravity is the distance between the objects. If two objects are far apart, the gravitational attraction between them would be less. If they're closer together, the gravitational attraction is much more. So that's another thing that gravity depends on, is the distance and the masses of the objects. All right, next idea. So, people used to think that the Earth was at the center of the solar system. That was called a geocentric model. I believe I mentioned that a couple days ago. But that geocentric model, people didn't know any better back then. So, as there's new technology available and people are able to make better observations and collect new evidence and make new discoveries, they realized that that wasn't correct. So there was a new invention at the time called the telescope, and that new invention allowed for a lot of new observations, new discoveries, and new evidence. And as scientists, or as we as humans, gather more evidence, gather more information, and make new discoveries, that allows us to have a more accurate model of the world. In this case, we had a more accurate model that led to the heliocentric model of the solar system, saying that the sun is at the center. Helios means the sun, and the sun being at the center is now the model that we use. Not only that, as we have in the modern times with space telescopes, spacecraft, space probes, not only do we realize that the Earth is not at the center of the solar system, the sun is at the center of the solar system, but the sun is not even the center of our galaxy. We realize that our sun is just one of billions of stars in the galaxy out in one of the outer arms. And then our galaxy is one of only billions in the entire universe. So in just a few hundred years, humans' understanding of the universe has changed dramatically. From just 400 years ago, most people believing that the Earth was at the center of the entire universe, to now we know that the sun is in the center of the solar system, which is only in an outer arm of our galaxy, which is one of just billions of stars, and our galaxy is one of just billions of galaxies. So the universe, and our model now, is a much, much bigger place than it had been in our imagination in the past. So with new ideas, new technology, and new observations, we have a more accurate understanding of the universe. Well, as always, stay curious. I'm off to go explore strange new worlds in my kayak. I don't know how far I'll get, but we'll see what I find out.